In this video, we're focusing on the axes of symmetry of a parabola. So we can use the axes of symmetry formula, because there is one, to find turning points of a parabola. So the formula we're going to be using is x equals negative b over 2a. And you'll notice that that is just essentially the starting point of the quadratic formula. Now, also something to point out when you're doing these type of questions, remember with a parabola, if the a value is positive, the graph is concave up, or a smiley face. And if a is negative, the graph is concave down, or a sad face. So here we can see a parabola in red, right? And then the blue line here, let me just write here, is our axis of symmetry. All right, we also have a point down here. Now this point is your vertex, so there's two things going on. We tend to use the axes of symmetry to find the vertex, all right? Okay, so a vertex, the key point is that it has two values. It has an x and a y value, where the axis of symmetry is usually just an x value. So here we have an example. We need to find the equation of the axis of symmetry of the parabola y equals 4x squared minus 3x plus 1. Then we need to state if it's a minimum or a maximum turning point. So the first thing I'm going to do is write the function down here. Underneath, I'll write my quadratic part. Okay. Now what I'm going to do is write the formula for my axis of symmetry, which was x equals negative b over 2a. And we can substitute those values in. So x is going to equal negative 3 over 2 times 4. And we end up with 3 over 8. So when x is 3 over 8, we know that as the axis of symmetry. All right, now the next part is state if it's a minimum or a maximum turning point. So a minimum or maximum, that has to do with this value here. And because that's a positive, we know it's going to be concave up, or a smiley face like that, which means it's going to have a minimum turning point. All right, so we can find the turning point using the formula. So when we use the formula, we find the x value of that turning point of the vertex. Once we have the x value, we substitute this into the original equation, right? The original function that we were given. That then tells us the y function, the y value, sorry. And then both of these together form the coordinates of the turning point. So here we have a function. Find the x-intercepts and state whether the function has a maximum or minimum, and then find its value and sketch the graph. So I'm going to use the quadratic formula here to find my x-intercepts. Now remember, if you don't remember, the quadratic formula is that, where your a value is the coefficient of x squared, b, and then c. So you would do your substitutions in, and remember it's plus or minus here, so you're going to have to do one with a plus, one with a minus, and you end up with two answers. Now they are a lot of decimals, so we will be rounding just for the sake of this one. So we end up with negative 3.41 and negative 0.586. Okay, so we've got two x-intercepts now. That's where it's crossing the x-axis. We want to find our, so up here, let's just quickly write this, x-intercepts. Then down here, what we're going to do now is find our axes of symmetry. And we're going to be using x equals negative b over 2a. So here, x is going to equal negative 4 over 2 times 1, negative 4 over 2. So x is going to equal -2. All right, so we're going to then use that to find our vertex or the turning point. So how we do this is we write out our function, so f(x) equals x squared plus 4x plus 2. And what we're going to find now is it when x is -2. So now we have -2 squared plus 4 times -2 plus 2. You can put that into a calculator and you get -2 there. So our vertex is at -2, -2. All right. So we also need to state whether it's a maximum or minimum. So our A value is positive, so we know it's going to be a minimum turning point. So using this information that we've found, we need to quickly sketch the parabola. So the first thing I want to do is put my x coordinates on there. So we had one down here at -0.5, and then our other x coordinate was up here at -3.4, and then we had our vertex at -2, so -2, -2, so here. And the last thing you need to do is essentially just draw your parabola in there. So it's going to look something like coming down and then up like that.